Hello students, I welcome you in today's class of physics. In today's session, we will discuss about calorimetry, which is the topic of heat. As you all know, in our previous lecture, we had covered out most of the topics of this calorimetry. Clear? So today we will discuss about, as you can see here, distinction between heat capacity and specific heat capacity. Fine. So we will discuss about what is the difference between heat capacity and specific heat capacity. So as you can see here, first one, it is the amount of heat energy required to raise the temperature of entire body by 1 degree Celsius. Clear? And what is specific heat capacity? It is the amount of heat energy required to raise the temperature of unit mass of the body by 1 degree Celsius. The second one, it depends on the mass of the body, whereas in specific heat capacity it does not depend on the mass of the body. The unit of heat capacity is joule per kg Kelvin, whereas the unit of specific heat capacity is joule per kg per Kelvin. Clear? Heat capacity, which is your C dash, is equals to mass into specific heat capacity. Clear? Whereas specific heat capacity, which is your C, is equals to heat capacity C upon mass. Clear? Now we will talk about specific heat capacity of some common substances. Here you can see. So the specific heat capacity of a substance is its characteristics property. It is different for different substances. If we heat equal masses of two different substances on the same burner so that the rate of heat supply is same, we notice that after the same interval, the rise in temperature for the two substances is different. This is due to their different specific heat capacity. Water has unusually high specific capacity, which is about 4200 joule per kg per Kelvin. You have to see the note here. The specific heat capacity changes the change in the phase of the substance. Clear? Means if you heat the water, so from liquid it vaporizes, so it changes its state. So the specific heat capacity of ice, you can see here, 2100 joule per kg per Kelvin, and whereas the specific heat of steam is 460 joule per kg per Kelvin, while that of the water is 4200 joule per kg per Kelvin. Clear? The specific heat capacity is maximum for hydrogen. The maximum heat capacity for which substance is for hydrogen, which is about 14,630 joule per kg per Kelvin. You have to remember this. The table below gives the specific heat capacity of some common substances. You can see here there is a table given, and you can see the specific heat capacity of different substances like lead, mercury, brass, zinc, copper, iron, glass, tin, etc. Clear? Now we will discuss about our most important topic, which is your calorimeter. What is calorimeter? So a calorimeter is a cylindrical vessel which is used to measure. Why which it is used? It is used to measure the amount of heat gained or lost by a body when it is mixed with another body. Clear? It is shown here in the figure number 11.1. You can see here, this is the figure of calorimeter. Clear? So now it is made of a thin copper sheet because copper is a good conductor of heat. As you all know, copper is the good conductor of heat and electricity. So the vessel soon acquire the temperature of its content. And the second one, copper has low specific heat capacity. You have to also remember this. So the heat capacity of a calorimeter is low, and the amount of heat energy taken by the calorimeter from its content to acquire the temperature of its contents is negligible. Fine. The outer and the inner surface of the vessel are polished. Why we polish the outer and the inner surface? So as to reduce the loss of heat due to the radiation. I hope you know the radiation, convection and conduction. The space between the calorimeters and the jacket means the outer layer. Here you can see this is the outer layer is jacket and the inner layer is your calorimeter layer, and we fill the space between the jacket, wooden jacket, and the calorimeter with a wool. Fine. So here it is written that with some poor conductors such as wool, cotton, etc. Why we insert a wool or a cotton here? Because to avoid the heat loss by conduction. Clear? So it is covered with a wooden lid to avoid the heat loss by convection. These are the three things you have to, I hope you know very well: conduction, convection and radiation. The lid has two holes, one for the stirrer by which we use to mix the contents, fine, used for proper mixing the contents of the calorimeter, and the other for the thermometer to measure the temperature of its contents. Now we will come to the principle of mixture or principle of calorimetry. This is the very important topic, you have to understand it properly. Clear? So what is say here? The principle of measurement of heat is based on the law of conservation of energy. On which principle the principle of calorimetry is based? So you have to remember the law of conservation of energy. So when a hot body is mixed or is kept in contact with a cold body, so heat energy passes from the hot body to the cold body till both the bodies attain the same temperature. Fine. If no heat energy is exchanged with the surrounding, that is the system is fully insulated, then you can write here the formula like this: heat energy lost by the hot body is equals to the heat energy gained by the cold body, or you can also say that heat given equals to heat taken. Clear? This is the principle of mixtures or the principle of calorimetry. You have to understand it properly. Now you can see here, let us a substance A whose mass is how much? M1, and specific heat capacity is C1 is at a higher temperature T1 be mixed with another substance B whose mass is M2 and whose specific heat capacity is C2 at a lower temperature T2. So where T2 is less than T1 means the second body's temperature is smaller as compared to the first one. So the final temperature of the mixture is become how much? T. In that case, how much there is a fall in the temperature of the substance A, you can write here T1 minus T. And how much there is a rise in the temperature of the substance B, so you can write here T minus T2. So by the principle of calorimetry, we can write here heat energy lost by A is equals to M1 C1 into following temperature, which is T1 minus T, and the amount of energy lost by A, same amount of energy gained by B. So we can write here heat energy gained by B equals to M2 C2 into rising temperature, which is T minus T2. So M2 C2 into T minus T2. So if no heat energy is lost to the surrounding, then by the principle of mixtures, you can write here M1 C1 T1 minus T equals to M2 C2 T minus T2. Clear? This is by the principle of calorimetry. You can write this. So the above expression, this one 11.8, can be used to calculate the unknown quantity. Means if you don't know the specific heat capacity or there is a change in the temperature, so by this formula you can calculate it easily. Fine. Now we will come to the measurement of specific heat capacity of a solid. 11.6 you can see here. This we will have to discuss it right now. How will you measure the specific heat capacity of solids? So what the procedure? It is given here. The first one is the given solid in the form of small pieces is first weighed and is then heated by suspending it by a thread in a beaker containing boiling water or any other liquid. Fine. Now the second one is, while the solid is getting heated, the empty dry calorimeter with the stirrer is weighed. The calorimeter is then filled nearly 1/3 with the water sufficient to submerge the solid and is weighed again. So the difference in the two readings give the mass of the water taken. If you have to find out the mass, so you will find out by this process. The third one, the initial temperature of water in the calorimeter is noted by which? Thermometer. You can note the temperature of initial temperature of a calorimeter by thermometer. So when the solid has attained the steady temperature, its temperature is recorded by the thermometer kept in boiling water. The solid is then gently dropped into the calorimeter carefully without splashing out the water. Fine. And the sixth one is the contents of the calorimeter are well stirred and the final highest temperature reached is noted. You have to note down the temperature. So what you observed during this procedure, these are the observation you have to remember. That is, mass of the solid is m kg, mass of calorimeter is m1 kg, mass of calorimeter with water m2 kg, initial temperature is water how much? T1 degree Celsius, temperature of heated solid is T2 degree Celsius and temperature of the mixture is T degree Celsius. Now you have to do some calculations. So after finally recalculate the above expression, I am skipping this, you have to study by yourself. Now we will come to the measurement of specific heat capacity of liquid. First one is we will discuss about the solid. Now we will take here the measurement of specific heat capacity of liquids. How will you measure the specific heat capacity? So the procedure is exactly similar to the described for the solids. Fine. So in this case we take a solid of specific heat capacity, how much? Small c. The solid must not react chemically with the given liquid whose specific heat capacity is to be determined. This is the or you can say that the rule, you have to not, the solid you have taken is not mixed with the liquid for which you are going to measure the specific heat capacity. The liquid is pushed in the calorimeter in place of water. If Cl joule per kg per Kelvin is the specific heat capacity of liquid, then heat energy lost by solid is equals to how much? Heat energy gained by liquid plus heat energy gained by the calorimeter. This is the principle of calorimetry we have already discussed about. So in place of heat energy lost by the solid, you can put the values and finally you will get the specific heat capacity Cl. You can see there, this is Cl is the specific heat capacity of liquid. That's why it is written as Cl. So if expanded polystyrene cup is used in place of calorimeter, what will happen if we use a polystyrene cup in place of calorimeter? Then neglecting the heat energy taken by calorimeter, so we get the above relation like this: Cl is equals to mc T2 minus T by m2 minus m1 T minus T1 joule per kg per Kelvin. Clear? Now there is an electrical method given here. What the method says? And according to this method, the specific heat capacity of a solid or a liquid can also be determined the electrical method. This is the electrical method. So how will you determine the solid and liquid specific heat capacity by electric method? In this method, heat energy is supplied by an electric heater known as power, whose power is how much? Capital P. And the rise in temperature is delta T. In how much time? T for a known mass of small m of a given substance is noted. Assuming that there is no loss of heat. Clear? So the energy supplied by the heater, which is Pt, is equals to the energy used, that is mc delta T, in raising the temperature of the substance. So we can write here Pt is equals to mc delta T. Clear? So finally you will get the relation here like this: specific heat capacity of a substance, which is C is equals to Pt upon m delta T joule per kg per Kelvin. Clear? This method is suitable for good conductors of heat such as copper, silver, aluminium, mercury, etc., since they get heated uniformly. I hope it is clear for you. Now there is another topic we are going to discuss here is the natural phenomena and consequences of high specific heat capacity of water. You can see here, there are the few examples given over there for these relations. Some consequences of a specific heat capacity of water are given below. The first one is the climate near the seashore is moderate. Why? So the specific heat capacity of water is very high. You know very well, it is equals to approximately 1000 calorie per kg per degree Celsius, or you can also say that 4200 joule per kg per Kelvin. So it is about 5 times as high as that of sand. Clear? Hence the heat energy required for the same rise in temperature by a certain mass of water will be nearly 5 times than that of required by the same mass of sand. Similarly, a certain mass of water will give out nearly 5 times more heat energy than that given by sand of the same mass for the same fall in temperature, such as sand or earth gets heated or cooled more rapidly as compared to the water under the similar condition. Thus, a large difference in temperature is developed between the land and the sea, due to which the land and sea breezes are formed. I hope you know the land breeze and sea breezes. These breezes makes the climate near the seashore moderate. Fine. Now the second one is hot water bottle are used for fermentation. The reason is that water does not cool quickly. The second one we are going to discussing here, this one. The reason is that water does not cool quickly due to its large specific heat capacity. So a hot water bottle provides the heat energy for the fermentation for a long time. Clear? Now we will move to the third one. Water is used as an effective coolant. Clear? You can see here this one, we are discussing here. So by allowing water to flow in pipes around the heated parts of a machine, heat energy from such part is removed. Example, radiator in car and generator are filled with water. Clear? So water in pipe extract more heat from surrounding without much rise in temperature because of its large specific heat capacity. Clear? So this is the reason why we use water as an effective coolant in our car and generators. We come to the fourth one. In cold countries, water is used as a heat reservoir for wine and juice bottle to avoid their freezing. Like Antarctica, where the temperature is very low. What will takes place there? The reason is that water, due to its high specific heat capacity, can impart a large amount of heat before reaching up to the freezing temperature. Hence, bottle kept in water remain warm and they do not freeze even when the surrounding temperature fall considerably. I hope it is clear for you. And this is the fifth one. Farmers fills their field with water to protect the crop from the frost. Here you can see that. In the absence of water, if a cold winter night, the atmospheric temperature is equals to how much? Falls below 0 degrees Celsius. The water in the fine capillary of plant will freezes. I hope you know the capillaries. So the veins will burst due to the increase in the volume of water on freezing. As a result, plant will die and the crop will be destroyed. In order to save crop on such cold nights, farmers fill their fields with water because water has a high specific heat capacity. So it does not allow the temperature in the surrounding area of plants to fall up to 0 degrees Celsius. Clear? This is the sixth one and the last one. All plants and animals have high contents of water in their bodies. You know very well. All plants and animals have nearly 80 to 90% of water in their bodies, so it helps in maintaining the body temperature nearly the same in all seasons due to high specific heat capacity of water. So that's all for the today's class, student. As you can see here, we have completed our topic here, and in our next class we are going to take some examples of high and low thermal capacity. You can see here, this is the next topic we have to discuss in our next lecture. So till that, students, do study properly, and thank you class. Thank you.